Alrighty, guys, I'm going to show you how to do the assignment for week 2. I'm going to go ahead and share my screen right now. This is what you should see on your Moodle page for week 2. All right. So basically, this is the main assignment we're going to do today. This is another assignment, which is pretty much the same steps as this one, but this one has less detail on specific steps. It's just kind of a reminder of what we're going to go through here. I'm going to go through both of them in this video. We're going to start off with the personalized template. So go ahead and download that one. If you took my class last semester, you can just use the template from last semester because it's the exact same thing, and you won't need to do these steps if you have that template saved. So first thing we're going to do is open up that template. So go into Civil 3D, open, go to my downloads folder, downloads, template. All right. So this is the one straight from Moodle. And what I want you to do with this, if you haven't done this before, is we're going to modify these 3 layout tabs. All right. And I want you to modify them so these display your name and not mine. So what you can do is just double click. And then this enhanced attribute editor should pop up, and we can change the values in this title block. So you can just type in your name, right? Your actual name, not your name. Okay. Do the same thing with this one. Do the same thing with this letter layout tab. And basically that's just going to give you a head start for all the rest of the assignments next semester. And this is probably the most important step right now is what we're modifying isn't actually it's a drawing. It's a DWT, which is a drawing template. All right. So what we're going to need to do is save this as a template. All right. So save as, make sure it's a template. Okay. And then you're going to want to save it in your H drive. So go ahead and make a folder for this class. And you can just call it, your name template. Okay. And then just hit OK. And when you close out of this guy, and then you want to start a new drawing, just go up to the file and then new, and it will ask you for a template. It says select template in this window, all right? So every time you start a new drawing in this class, just go and reference back to that template we just created, your name template, all right? And now when you hit open from a template, you see how this is a DWG file up here? Now we know that we're modifying an actual drawing, not modifying the template, all right? So that's the first step of the assignment for this week. Set up your template. So one thing we're going to do is we're going to play with automated line work. So basically, what we did last semester mostly was importing points, survey points, basically just data that you get from a surveyor. What we're going to do is have AutoCAD actually connect dots within those points to create lines. So if you have like the edge of a curb that somebody surveyed and you want to include that in your drawing, you can use the data involved, or you can use the data from your survey to actually draw a line automatically. All right. And so that's what these line work code sets reference to. They have these different codes in the survey data that refer to beginning a line, continuing a line, ending a line, closing a line, offsets, and basically all these different things that you can add onto your survey data to begin and close lines and draw things automatically. Okay. So that's what we're going to do is actually set up one of these line work code sets. So when you have your new drawing open, we're going to go to this survey tab. All right. Let me go back to the steps real fast. Okay. So we're going to go to the line work code sets right now and hit new. We're going to call this one week 2. Oops, week 2. This is our line work code set that we're creating. And these are the different codes that we're going to use to have AutoCAD draw things for us. And I want you to fill them out the same way that it shows in the PDF of the instructions. So we want to make sure this guy's an / automatic begin on figure prefix match, push, have that guy say yes. So this guy's going to be a / yes. We want the beginning to say BEG. Continue, we want it to say C. End for end. Close CLS. Okay, HVSO, RPN. I believe these are all the same. And we're going to add this BCV and ECV for begin and end curve. So BCV, ECV, and then hit OK. And you'll notice that you may have the sample one bolded right now. What you want to do is make sure week 2 is bolded. So right click and hit make current, which will show that week 2 is the current line work code set in the drawing. Next thing we're going to want to do is create a folder for this class on your H drive. And then you'll want to have your template saved into that so that you can always refer to it. And the next thing we're going to do is right click on survey databases, hit set working folder, and we're going to refer back to the H drive, your folder for this class. I'm going to hit week 2. All right. So week 2, and you probably won't have these on here. Yours will be blank. So the next thing we're going to want to do is right click and hit new local survey database. I'm just going to go week 2.3 because I've done this a few times, it looks like. And then hit OK. And then just hit OK, ignore that warning. And then the next thing we're going to do is right click on the newly created survey database and hit open for edit. And then you'll see all these options in here for what we can do with all of our survey data. And okay, so basically these are the ways that your survey data will be imported. The ones that we're mostly going to use for this class is this order, which is PNEZD. P refers to the point number, N for the northing. So that would be like your y-axis. If you're looking at the entire Earth as a grid, your E would be your x-axis, and then your Z would be your elevation, and D for description. Okay, so all those things are referring to your data beta or your survey data. So the next thing we're going to want to do is right click on import events, click on import survey data, and then select the newly created survey database. We're going to want to download this topo survey text file. Okay. I Actually, yeah. So instead of downloading it from here, it looks like Chrome won't let you download directly a text file. So go ahead and download this required files folder, and it'll be a zipped folder. And then what I always do is just right click on this little download window and hit show in folder. And then with the zip folder, you probably already know this, but you're gonna have to unzip this guy. So right click on it, hit extract all, which basically is just going to uncompress this folder. And we want to browse to our H drive, Civil 3D 2021, week 2. All right, and I'm gonna select this folder. Okay, so now it's going to extract, replace. All right. So week 2. This is the file that we want to import, this topo survey text document. All right. So go back into the import survey data window, hit this plus to browse, and then we want to go back to week 2. Week 2. Week 2. Topo survey. That's the one we're looking for. All right. Hit open. And then you want to make sure that you have PNEZD selected, or else your points won't import correctly. So then hit next again. And then you're going to want to make sure and select this insert survey points. And then this line work code set, make sure it's on week 2. This one you won't have quite yet, so you just leave it on sample. But make sure this line work code set is set to week 2. Finish. All right. So basically, the line work code set actually drew these lines based on the survey data. So if you were to look at the text file with all the survey data, like if I go back here, this topo survey text, see how it says BEG, ECV, end ECV, BEG. This is basically just telling AutoCAD where to begin, end curves, begin and end line. And yeah, so based on these codes and the line work code set, we were able to have AutoCAD automatically draw all these white lines right here. Alrighty. So let's go back to the destructions. So this is just kind of a review of contour lines and contour maps. Basically, contour lines refer to, like if I show you a topo map, these would refer to, or are called contour lines, okay? They're lines representing equal elevation. So if you have lines that are really close to each other, that means that your terrain is really steep. And these lines that are more spread out apart are more flat areas, okay? So this is just kind of zooming into the bench. So it looks like 5,080, 5,100. So between this point and that, between this line and that line, there's 20 feet elevation change, okay? So if you think about how close these are, that's 20 feet, 20 feet, 20 feet. So you're dropping pretty quick right there. Whereas if you actually look in town, you know, you hardly see many changes on these topo lines. All right. 4,400. And this other interval looks like, I can't see it. But it probably only changes, you know, maybe 20 feet from here to there in elevation. So you got a lot more flatness going on. in town compared to on the bench, right? So your contour line should never intersect because it would be impossible to have, a point that has two different elevations. It should never cross. And the water would flow perpendicular to a contour line because the, perpendicular to all these topo lines would be the path of least resistance, basically. So if you were to, draw a line perpendicular to all these lines, that's exactly where water would go. As you can see, there's an actual creek here, which is, perpendicular to every contour line there. Alrighty. V-shaped channel is formed by adjacent contours. Water will run from the small end to the large end of the V. Think of this as a reverse funnel. So yeah, there's a nice example in this, part of the map. If you think about, equal elevation, it's exactly what would happen. You have a reverse V, and that's where the water would go, right? A little valley. And so another thing we're going to do in this assignment is go over contour boundaries. So you can have outer boundaries, you can have hide boundaries, you can have show boundaries, and data clip boundaries. So for example, if you wanted to build or hide or create a hole in our 3D surface, like for example, a building location, you can draw, a rectangle outlining the outside of the building and then add that boundary onto the surface. And it'll basically just poke a hole right in your surface. Break lines basically are lines that force your 3D surface to bend along the line. So like if you had the edge of a curb or a sidewalk where that the geometry bends along the line, you can add a break line. So you're basically forcing your surface to bend along those lines. So the next thing we're going to do is we're going to create a surface. Okay, we've already imported the points. Next thing we're going to do is create a surface, add the points to the surface. Alrighty. So go up to Prospector, right click on surfaces, hit create surface. And what I'm going to do is type in EG for existing ground. Let's see what the instructions say on the style.
Oh.
Proposed usually stands, or PRO typically stands for proposed ground. We're going to change the surface style to contours 2 and 10 design. Alrighty. 2 and 10 design. All right. Okay. And then one thing that I skipped, I'm going to go back up on the instructions. We're going to modify one of these styles. Okay. So we're going to go on tool space to the settings tab, and we're going to expand point and then expand label styles to the style called point number elevation description. That is the label style we're going to modify. So if I go to settings, expand point, expand label styles, point number elevation description, I'm going to right click and hit edit. This is where you can actually change the style. So I'm going to go to this layout tab, and this is our point number, and then the elevation and the description. Okay. So this is each component individually. So you can change the colors of each one of these individually if you'd like. For this assignment, we're going to modify the point description to be color 2 or yellow. All right. So I'm going to go to the description, change the color right here to yellow. color 2. All right. Next thing we're going to change is the elevation to cyan, or color 4. So elevation, cyan, or color 4. And then the last one is the point number to red. So point number, red. There it is. And then hit apply, OK. Alrighty, and we've already created a surface. Next thing we need to do is add the point groups to our surface, okay? So I'm going to go back to the Prospector tab, expand surfaces. We have our EG surface, expand definition, right click on point groups and hit add. And this is our survey data that we imported. You can either select this one or all points, because this is literally the only point group we have in the drawing at the moment. So I'm just going to hit all points, OK. And there we go. See, we have our topo lines, our contour lines. As you can see, they don't intersect because those are points of equal elevation. All right, well, they shouldn't intersect anyways. So I'm going to show you what surface triangles are. So if I were to change the style to, so if I select this guy, I can go to surface properties. If I change this to contours and triangles, you'll see that there's basically a bunch of triangles that are mathematically generated, creating a surface. So if you think of this as like a wrinkled piece of paper, all these lines would be our various folds or bends in the paper, okay? So when you have a break line, you actually force AutoCAD to bend in a certain way. And we'll go over that later, but I'm going to go ahead and change this guy back to 2 and 10 design. Okay. I got our style back. Alrighty. Okay, so the next thing we're going to do is we're going to actually extract the outer boundary from the surface. So what you can do is select one of these contour lines, go to the surface tools, hit extract from surface, extract objects. What we're going to do is deselect major and minor contours and only select the border. Hit OK. And now if I hit escape to clear my selection, I can see that this is the line I just extracted, okay? If I right click and go to properties, where's my properties? I'm just gonna type in properties maybe. There we go. So now we have our properties window open. So when I select this outer line, it'll show me it is a 3D polyline. And in order to use this as an outer boundary, it will not work with a 3D polyline. So what we need to do is convert our 3D polyline to a 2D polyline. The way you do that is you go to this Modify tab up here, and then click on the down arrow on Design right here to expand. Convert 3D to 2D polylines. And then just go ahead and select our outer polyline, hit Enter. And to double check that it worked, you can select it and look in your property window, and it'll just say it's a polyline instead of a 3D polyline. Okay. Next thing we're going to do is in Prospector, we can expand surfaces, expand EG, expand definition. Right click on boundaries and hit add. And we can just type in outer because we know this is an outer boundary. Hit OK, and then select our polyline that we just made And now you can see that we have an outer boundary. All right. I'll just show you what an inner boundary would look like. All right, so I'm just going to do polyline. I'm going to just draw, a rectangle more or less based on this square. So we have this polyline here, survey. Oh, want a polyline. Anyways, so if I right click, hit add, and I type in inner. Frick. Oh my gosh. If I can type. Inner. Type. Hide. And then I can select my polyline. You see how my topo lines don't go through the building anymore? And that would be more realistic, right? So now we have an outer boundary, we have an inner boundary. You don't really need to do the inner boundary for the assignment, but I just wanted to show you what an inner boundary looks like. So you can see how, it's hidden where your building is, right? So the next thing we're going to do is set up our viewport on our letter size layout tab. So go to the letter size layout tab, double click in the viewport, unlock the viewport. And what I'm going to do is hit Z, enter, E, enter for zoom extent. There we go. Oh yeah, and one thing I may have not mentioned is that if you notice that the style isn't the one that we changed, what you need to do is select one of these points, right click, go to point group properties, and then change the point label style to the point number elevation description, which is the one that we modified. Now you can see that we have a cyan right here for the elevation. And so what I'm going to do is create a custom scale here because I know that none of these are going to work. So 1 equals 300 will work with a letter-sized piece of paper. Okay, and then I'm going to go ahead and select that scale I just made. And then lock my viewport. And normally what I would have you guys do is actually viewport freeze the layer showing these points because it's kind of a mess right now. But for the sake of this assignment, I wanted you to be able to modify the style to show color. So I'm going to have you leave the points on. And to add the north arrow and scale bar, you can just double click out here or hit PS enter to go back into Paperspace. Click on our north arrow tool. Select our viewport boundary. And then you can select the north arrow and then make this guy bigger. And then do the same thing with the scale bar. Select our viewport. And we know this guy is 300 feet. And then just select to place our scale bar. And then the last step is to print this guy off. So right click plot, plot a single sheet. And then what you want to do is make sure that this guy is set to none, because if you leave it on monochrome, it will print in black and white, basically. So none. And then if you're at the college, you can select the color printer, which is 132 CLJ, or if you're remote, you can do DWG to PDF. Yep. And then preview. And it looks like my PDF printer is a little bit off, but it really doesn't matter too much. If you wanted to go ahead and play with the settings to fix that, you can. And then just right click plot and you can email it to me, or you can just, turn in the piece of paper when you actually print it out. Oh yeah, and don't forget to change this guy to say week 2. Oops. Week 2. scale 1 inch equals 300 feet. Sheet 1. And there you go. So that's that part of the assignment. So that's basically, the first half. All right. And the next half refers to this other PDF here, homework 2. And all of these refer to this text file, this homework 2 survey text file. So go ahead and download that. Or I believe this file is actually in that same folder that you downloaded earlier, in that zipped folder. Oops. Yeah, so if homework 2 survey, there it is. That's the one that we want. So you can open this guy up and you can either answer the questions by looking at the text file, or what you can do is just wait till we actually import that data into AutoCAD and then find it there. All right. So it's similar steps. So what I want you to do is go ahead and you can save this drawing. So make sure it's on your H drive. Save week 2. It's going to save done week 2. Save. All right. And then what I'm going to do is start a new drawing. So new from template. Go back to our template that we made. Right. Your name template. Okay. So what we want to do is do the same steps. Go to the survey tab, right click, set working fold. Actually, no, go to new local survey database. Type in homework 2 or week 2 homework, whatever you want to call it. Homework 2, right click, open for edit, import events, import survey data. Next, and then go ahead and reference to this homework 2 survey text file. Open, PNEZD, next, and yes, week 2, yes, finish. Okay. And this is what it should look like. I'm going to right click on survey points and hit zoom to. And there we go, brought me in closer. Alrighty. And the next thing we're going to do is, let's look at this guy. So what is the elevation of 0.13? So what you can do is move this little barrier up. And you can look right here, 0.13. And there's the elevation, 4890.65. What is the description of 0.27? So I can go down to 0.27. The description is edge of asphalt, right? You can go ahead and do that same thing for all of these. Next step is create a surface and show the contours on the survey data. So I'm going to bring this guy down again. Go to the prospector tab, right click, create surface. I'm going to call it EG. Oh, right here actually. EG, style. Let me just review the instructions here. So one thing I'm going to have you do later is to have the major contour as color 52 and the minor to 42. So I might as well just do that now. So I'm going to go to the style, and then I'm going to go to 1 and 5 design. And I'm going to actually modify that now. So edit current selection, go to the display tab, major contour, 52, minor 42. All right. So I'm going to go ahead and click on this number or this color, 52. Okay. Click on this color, 42. Okay. And then okay. I'm going to expand surfaces, expand EG, expand definition. Right click on point groups, hit add, all points. Okay. Boom. So there's our color 52 and 42. There's our surface. Modify the color settings of the point labels to point description to be yellow, elevation cyan, point number to red. So one way you can do that is going into the settings and then finding which one you want. Or another way you can do it is to zoom into one of these points, right click, go to point group properties. This is the point style that's current, so I can go ahead and hit edit current selection. Alrighty. Point description yellow. That's what we want. So description yellow. Alrighty. Elevation cyan. And point number red. Red. Okay. There we go. Should update. So zoom in, print an area, letter size piece of paper. So same deal as before, right? Go to letter, double click in your viewport, unlock it, change the scale, custom, add 1 equals 300, 300, okay, okay. Then go ahead and select the newly created scale, zoom extents, select the scale, there we go, lock it. And we're gonna leave all these points on so I can see that you change the colors. And I'm gonna type in PS to go back to paper space, north arrow, select the viewport, place the arrow, zoom in, select the arrow and scale it. There we go. Scale bar, select the viewport, 300 feet. Put that up here. It's kind of on top of my letters there. Let's go up a wee bit. There we go. And same thing, right click, plot, single sheet, okay. Make sure this guy is set to none so it actually prints in color. Choose your printer and then okay. Alrighty. And this one, what is the appropriate scale to print the drawing on a letter size? You already know that, right? It's 300. That's what our viewport was set to. And that is the part 2 of the week 2 assignment. Let me know if you have any issues, and I will see you later.